Okay, so I'm making this video to give a few people a different option in programming their VESC, or making things more simpler if they are going to be making multiple VESC, or if they're continuously programming or updating firmware, reprogramming, things like that. And I know one of the pains for me, because I'm constantly doing different things with my board, is every time I update my firmware, I have to reprogram my VESC. It doesn't take that long to do it, but it still is a little bit of a pain. So I'm going to demonstrate this in Ubuntu. That's the environment that Benjamin Vetter has really created everything in. But this can be done in any environment as long as you know how to compile the firmware in that environment. But yeah, it doesn't take very long to do this, and it can save you a little bit of time in the long run. What I'm going to do is I'm going to go into basically my home, BLDC tool, and then I'm going to go BLDC tool. Now I'm going to start off explaining for using Bluetooth how to change the baud rate of BLDC tool. There's lots of files here that basically do what tell the program and the software what to do, but not all of it's used not all of it is going to be used for making changes to BLDC tool. The main one that I've been using is mainwindows.cpp. This is where you change the baud rate. This really contains settings behind the scenes for BLDC tool. This one here, main window H, has a lot of configuration files or preset settings into there. Basically, when this is your user interface of BLDC tool. So in the previous versions of BLDC tool, in OS 10, some people were having trouble with the fact that the default serial port was basically 206. 206 when it needed to be 301. And then I manually changed it in here and compiled it and then sent it out to everyone, and it made it a little bit easier. For a while I had two boxes that if it wasn't one port it would default to the next port, but all of that doesn't matter anymore because we use vendor ID. Now I'm going to show you the baud rate in mainwindow.cpp. .cpp, for many of you, you will recognize it as a C++, basically code file. When you get into more complicated coding, there's lots of C++ files here, and generally if you were coding in NetBeans or something like that, you would have, starting out with your .cpp, these, basically if we open this, right now it opens up in Qt. You don't have to open it in Qt. You can open it in a simple text editor as well. Qt is a little bit easier because it's all numbered down the side, but we're including all these dependencies here into this file. We're going to scroll down because I'm just showing you how to do the baud rate at the moment, and we're going to scroll down all the way until we see around about 2000. Now you could do a Control F to find what you're looking for, but I'm doing this because it's simple for people that don't know much about using environments like Qt. And there it is, baud rate. I've already changed this to 9600. It defaults at 11,5,200. Now you need this baud rate if you are going to use Benjamin Vetter's UART code for communicating with another STM chip, or if you are using Roland Gecko's UART nunchuck. but a Bluetooth chip like a HC-05 can be a bit hard to change the baud rate inside of them, but the default is 9600, like that. And basically you just save this and then you can exit. There's a few other things that you can change in here as well, so if you're messing around with nunchucks and things like that, NRF chips, you can change settings for your sleep timers and things like that, serial ports, everything. But I wouldn't recommend you should be changing this stuff. I'm just showing you how to change the baud rate in this file. The next thing that I want to show you, if we jump out of here and we go into the firmware file. The firmware, there's again lots of different files. You won't be using all of these, but you can explore them. I recommend that you look at them, don't change anything, but just look at them, because you might discover things that you can change that you didn't know that you could. I'm going to go into the start off with motor configuration right here. This is the default file that Benjamin Vetter uses. Because I'm going to open that right here. This is just opening in a text editor. So when you first update your firmware and you go read data, this is what will show up. This is the data that Benjamin Vetter has set. It's very self-explanatory. Right here, it says motor type, BLDC. If you change this to FOC instead of BLDC, then you have it set to FOC. If you change it to DC, then it's now in a DC mode. This is your PPM, your censored mode, communication with things like that. This is your limits, so your max current for phase, your current regeneration, so regen, and then your max in current, and then your breaking current as well. Now, these limits here, this is what you would mainly change in BLDC tool, and then you've got your voltage and things like that, but lots of people don't even set them. I actually think it is quite good to set them if you're using LiPo batteries and don't have a BMS. But you can change these settings right here. We can go down, you can change your RPMs, your duty cycles, your braking RPM limits and things like that. But what we're going to do is we're going to focus on a couple of sections. This one right here, some of you will change. This is your startup boost. If you change this a bit higher, 0.03, then your motors can start up a little bit better. Move down here, this is your motor configuration tab that you would normally do your motor detection in BLDC tool. If you have done a detection and you're like, I want to make a firmware that's set for my motor, I don't want to change anything else on there, I just want it to be configured because I've got a special motor that no one else has, I'm selling it, or I just want to be able to load these configurations really fast when I update firmware, this is how you can do it. So normally you change this one and you change this one. If you want to go, if you have sensors in your motor and you know the table, you can change them here, and then you can change what RPM they kick in at. So you change all these parameters as if, so it's basically mimicking exactly what BLDC tool says. This is your FOC, as it says here, FOC tab, and you change all these settings. When you're changing the FOC tab, you need to make sure that you're changing the right setting. Benjamin Vetter has done it from a left to right type thing, so you'll go from one parameters across the room, and it can get a bit confusing. when you're doing it, but make sure that you're reading. Sometimes there's comments here that you can look at changing. But you got your motor resistance and your other settings like that. Observer gain, flux linkage, all of that. Now, if you change all these settings, there's one thing that I want you all to remember doing is Benjamin Vetter often updates his firmware with the latest settings that should be in there because he's been testing it and figured that these settings are better. If you leave all of these in there, then you can very well just come in and change these manually and leave it as default, but you can make a file to basically make it so it builds your settings and only the ones that you've specified. So what I would do is, if I didn't want to change all of these settings, I still want BLDC and everything, but I want to change my motor amps, I would just delete that. And let's say I want 40 amps here, I would just change that, and I want 40 amps here, but I don't want the rest. So I'm going to go after the end if, and I'm going to delete all of that because I don't need to change those settings. I don't need PID, position control. I do need the BLDC tool tab right here. So I'm going to delete all of that. I'm going to leave this BLDC tool indicator there so I know what it's for, but I'm going to change this to, say, 750, and this one to 300. These might, or definitely not, parameters. I've not taken these from anywhere. I'm going to delete that one up the top. I'm going to delete this one, and then also delete that one. While I'm there, I'm going to delete the next one as well. Oh, no. And delete these ones. And I don't need the whole sensor table because I'm not using censored. Okay, so I swap between BLDC and FOC all the time, so I'm also going to change some of these settings, but I'm not actually going to do them properly. So I'm just going to change my resistance to 1.3, and then this one is in engineering notation. So you need to do calculations to actually work out what your observer gain is. It's not going to be the same as your VESC, but I'm going to leave that as it is. And I'm going to change this one to 200, and then I'm going to delete all the ones below that because I don't need them. Okay. Can't delete this bit down the bottom, so I'll go back up. Okay. Okay, so I've deleted that. I don't need to change any of these, so I'll just go up.
Ava, come inside, please.
And I'll get rid of them. So then I'll get a little tiny field right here. I'm going to change this to sample because I want to change the name. And then down the bottom as well, I'm going to change it to sample, but leave it in capitals. And then I don't want to save it. I want to save it as a new file. So what I'll do is I'll just copy this. So I've pasted a copy, and I go back to my text editor, press save, and now back to my window. Rename sample. Okay. If I did that in Qt, it would have been easier to just save it as a new document. But I've still got my default, don't get rid of that. But I've got my MC config right there. I've got my own little one for inertion motors, which is for a 6355 inertion aspect motor. If I open up that one, you'll see I've got all the configuration for the motors that's recommended by inertion, all the motor configuration, and then the Fox settings right here. And then I've named it, looks exactly the same as what we have just made. I'm going to exit them, and now go back into here. Now the next thing we're going to do is the application configuration. Here's the default file right here. Same as explanatory, so that's the name of it, of the file. That's what's used in dependencies, so what you're including and things like that. This is the controller ID, timeouts, timeout for braking. You come down here, status over CAN bus. You change this one to app_NRF or PPM, depending on what you're using, ADC, and then you can change your PPM settings and everything here. I'm not going to go through that and show you how to do it because that one's quite self-explanatory. I'm just going to show you the one that I've made for myself, for inertion, which is this one here. Now this has all the settings that need to be changed in it. Benjamin Vetter also has one which is very small, which is the app PPM. This changes it to PPM, does nothing else. Everything else stays default, and then changes it to current with no reverse, as you can see there. Now we're going to go into the firmware folder right here, and we're going to find config general H and open it. This is the one which you would change what hardware version you're using. So at the moment the latest one is 4.10. If we want to change that, so this one's done for 4.6, use comments. Comments change from usable code to a comment about or a description about the code. So if we comment, it turns blue in this application. In other ones it's green or grey. And then we're going to remove the comments for 4.10, also 11 and 12. And that means that our hardware, our firmware's very importantly, configured for the hardware that we're using. This next section right here is for the motor configurations. So select default user configuration. So if I put a comment here, it's default. There's nothing else that you can do. Or it's going to just have the default settings. If I decomment this one, which is the default enertion .h file that we've just created, or if I comment them and simply just copy this, right there, then I've got another enertion one. But what we're going to do is we're going to remove that and rename it sample, and then that's got the settings that we wanted that we've just created with you in this video. This one here is to define your application configuration. So this one here is default enertion. I've created that one, put it in there. If we comment that one and just change it like this, it'll use the default one that Benjamin Vetter has in his firmware. If you decomment this one, it just changes the ppm settings to the one that Benjamin Vetter has set up. There are other settings that you can change here, but I don't think it's really needed. So we're going to use the enertion 1 at the moment. So I'm going to close that. Close without saving because I don't need to save it. I already got those settings there. But you would. And then we're going to go back into here. Now you've previously built your firmware. So what I'm going to suggest you do is just rename it. Don't delete it. And just call it build 2. Now we're going to jump into terminal. And we're going to cd to our folder. So in my computer it's, and most of yours should be, it's BLDC. And then we're going to cd to the next one, which is BLDC dash firmware. And now we're in this file right here. The next thing that we're going to do is just type make. We don't need to do upload unless you want to actually upload it to your hardware, to your VESC, and you've got it connected in the way to do that. But in this way, I'm just going to click make. Now it's compiling that firmware with all of the settings that I've just put in. Now this can take a little bit of time, but if once it's finished, we go into the build folder, you've got a bin file right here. That's the one you use in BLDC tool, so you can name this one whatever you want, and then next time you need to reload firmware, you load this one, and it'll have all of your motor configuration that you've preset. So it would be really good for companies like Boards or Talkboard with his DIY Escape company, or any others that are doing a custom firmware for a specific motor. You don't want to really do this if it's not going to save you time, but for those people it's going to save them, or customer support is going to save time. But this bin file is what you need to use. And you simply load it into BLDC tool. going to firmware tab, choose, and then choosing the file that you've created depending on where you've stored it, and then that gets loaded. The other thing that you can do is you've already CC'd to this file folder. I'm going to go back into firmware, and I'm just going to delete this one, and then go back into terminal. So I've already CC'd to my firmware, so I'm going to go git pull. Now it's going to download VESC's latest firmware files, and we'll just wait a second for it to do that. Okay, so that's happened. So before it was version 2.15, now it's version 2.16. So I can just stay in there for the moment. Now we'll go back into config general. All these files have been updated. And we'll check we went into the wrong one. Remember .h. Okay. So all of the settings that I've put in there, being inertion, is still there. So this is where you start saving time. You've already created that file, you spent maybe 10-15 minutes doing that. I'm going to define this to version 10, and I'm going to hit save. So as you can see, it's already inertion. Now I'm going to exit this and go back into my file. I've changed that to 2, so now I can build it again. So I'm already in this address, so all I have to do is type make again. Okay, so that's done. So I'm going to exit out of that now. I've got a build file here. So I'm going to rename this again. 2.15. And now this one, I'm going to leave as. I'm going to get this bin file and I can upload it to my VESC. Now I've got 2.16 and all my settings are there. So that's how quick it is to update your firmware with your configurations, and then you can distribute that. Thank you very much for watching. I know that this was a long video, but I really want to share more and more information. There's a lot that we can do with the VESC BLDC tool that people don't know or don't understand. Again, warning, do not do this if you don't know what you're doing, but use it for a learning process. It will help you understand how BLDC works a little bit better. So thank you very much for your time.